Hi and welcome to PowerPoints. We're here in Overland Park, Kansas. We're at the Black Veatch World headquarters, and joining me right now is Aaron Attebery. Aaron is an intelligent solutions engineer here at Black Veatch. Aaron, thanks so much for your time today.
Yeah, I'm glad to be here.
Aaron, there is an important asset management tool here. It's a control room where you monitor 100 power plants that has a capacity of 30 gigawatts. Can you tell us a little bit about that control room, some of the information that you're looking at, and some of the problems that you can identify as a result of the collection of data that you get?
Definitely, Russell. Yeah, so Asset 360 is the Black Veatch proprietary software platform. We're pulling in lots of plant process data, and we're talking about generating facilities. They have thousands and thousands of temperatures, pressures, and flows that we're pulling in on a minute-by-minute basis. And we use an alerting engine, so advanced pattern recognition software, that we build these dynamic models on top of this process data. We pull that in, and through diagnosing issues that come up through variables that move, heat rate calculations that move, or certain performance calcs that we perform, whether it's on a pump or a coal mill, or that could even be a solar plant or even a wind turbine. We pull that data in, and then we're able to tell the client about an issue before they even get an alarm on it.
What kinds of problems are typical? What kinds of problems do you identify for power producers?
So quite a plethora or range of problems that could arise as a generating facility, as you might understand. But a lot of times it comes down to reliability, bearing temperatures and vibrations on rotating pieces of equipment, since we do generate a lot of our power that way off the steam turbine, if you will. So definitely that. Inverter-based issues, when we look at our solar plants, we've got inverters that get derated if it gets too hot. Looking at pump degradations, just a small handful of many of the issues that we kind of find.
I see. And you use a series of algorithms to identify these problems. And when these problems are identified, are there alerts that go out to the utility or the IPP?
So the way that works is as engineers and process engineers, we understand how these pieces of equipment work. So we know the inputs to certain outputs. That's how we build that dynamic model. We know what inputs are going to affect a certain output.
I see.
As the engineer team here in the control room, we're able to kind of go through that list and identify real issues or false issues. We do a lot of that legwork for the client. And then when we identify a real issue, we will push it to the client.
Yeah, right. And the control room is manned 24 hours, 5 days a week?
5 days a week, that's correct. We do 12 hours here in the United States when we're awake, and then when we're sleeping, we know that power producers don't shut the lights off. They're still producing power, so Pune, India, we have a team there, and they pick up the night shift.
Well, thank you, Aaron. You're doing a lot of fascinating work in the area of asset management and your own microgrid system here at Black Veatch. Now let's go ahead and take a look at that innovative control room.
And now we're here at the Asset 360 Monitoring Center, where we're monitoring over 100 power plants, up to 30 gigawatts of generation. We've got a team of engineers here that are looking through our advanced pattern recognition models. We've got all of our clients here on the left-hand side, and right now this top one, air heater, hot end bearing temp, so we're seeing that bearing temp is alerting high. The upper limit's 149 Fahrenheit, but it's alerting at 164. The plant control room probably won't have an alert limit till like 212 or something like that. They're not looking at more of a predictive failure type. They're looking at hard stop, hard limit, and they might not even be able to react until the piece of equipment actually shuts off. These guys are constantly looking at these all day long. They'll dive into one of them. That's what we call a diagnostic drill down. So we've got that temperature on this bearing on that piece of equipment, that mill that's grinding up the coal. We kind of see how that's been operating over the past 10 days, but recently we see it spike and take off. And where that highlighting is, that's when we see an alert. So we take a screenshot of that, we can annotate the trend. So here we said all mill bearing temperatures are increasing simultaneously. We post those processes to the client, and then we work on that collaborative environment back and forth to resolve issues.